Hi everyone, welcome back to the course Manufacturing Process. Today we are going to discuss about machining operations. In machining operations, we are going to discuss about the different machining operations such as turning, drilling, milling, machining centers, and other machining operations. What is machining? Machining is a material removal process using a sharp-edged cutting tool, and we remove certain amount of material from the workpiece to change the shape and size of the workpiece. The most common application is just to change the shape and size to produce cylindrical shape or rectangular shapes, etc. So such kind of operations to remove the material from the workpiece by using a sharp cutting tool, that process we call it as machining operations. Workpiece produced will have either cylindrical shape or prismatic shapes, non-rotational prismatic shapes like blocks, plates, etc. So these kind of products are produced by machining operations. Advantage is accuracy is good, finishing also good, much better than other shaping processes. Only the disadvantage is some amount of material need to be cut or removed from the workpiece. Now, machining operations to produce a particular shape can be done in two ways. In first way, we generate by controlling the trajectory, the feed of the machine tool, we can generate the shape, and also by the shape of the cutting tool. So the part geometry is created by shape of the cutting tool. So here we could see here five conditions. The first condition is a straight turning process in which the shape is controlled by feed of the tool. If the tool is fed in horizontal direction, if the tool is fed at an angle, we could produce tapered work parts. And if the tool is fed in a curved shape, like contour turning, we call it as a contour turning, it follows a curved profile, then we could produce a curved surface. So in all these three cases, we adjust or control the feed. Now we can see in plane milling and profile milling also, we could produce the similar shapes. Now, forming to create shape, for example, if you use a tool and tool has a shape, that shape can be produced. This is the second category, how to produce a particular profile. Here, forming tool is used to produce a profile like this. Similarly, drilling tool could be used to produce a hole. So the shape of the tool will be the final product, or we can see the shape of the tool will be transformed to the final shape of the product. This is a broaching process where we have the slots, etc., which has the same shape of the tool. So another example is here. We can control the shape. We can control the feed as well as using the shape of the tool. So combining the feed and shape of the tool, we can have two processes. First is thread cutting and the other is slot milling. In thread cutting, threads are produced using this. We move the tool and the threads are produced. In slot cutting also, we produce a shape by controlling the feed as well as the shape of the tool. You could see here in a threading tool, the shape of the tool will have the shape similar to the shape of the thread, and feed also controlled. So feed as well as the shape of the tool will affect a process. Such a process is a combination of both controlling feed as well as shape of the tool. Now, what is turning operation? Turning operation is an operation in which we use a single point cutting tool to remove material from the workpiece. This turning operation is normally done in a machine called a lathe machine. So various turning operations are facing, contour turning, chamfering, cutoff, and threading. And in a turning and facing operation, turning operation is done when the material is rotated, material fixed in a machine called lathe machine in the headstock, and the machine and the workpiece is rotated at a particular speed v, and the tool is fed at a particular feed rate or at a particular feed F and with a particular depth D. So certain amount of material will be cut and removed from the workpiece. So this is basically used to produce cylindrical objects. So here initial diameter is D0 and final diameter is DF. The depth of cut is D. So we produce the final cylindrical object using this. So this process to produce cylindrical object is called a turning. Another operation is called the facing, in which we remove the material from the side or from the end faces of the workpiece. This process is called a facing operation. In both cases, we use a single point cutting tool in a lathe machine. Contour turning, instead of feeding the tool parallel to axis of rotation, tool allows a contour that is other than the straight, thus creating a contour shape. This is called contour turning, done in the lathe machine itself. Chamfering process is the cutting edge cuts an angle on the corner of the cylinder, forming a chamfer. So the chamfer is formed by this tool. This is called a chamfering process. Then cut-off process, tool is fed radially inwards into rotating workpiece at some location to cut off, to remove certain part from the material. So the workpiece is rotated and the tool is fed radially inwards into the rotating workpiece. Threading is pointed form tool is fed radially inwards linearly across the surface of the rotating work part parallel to the axis of the rotation at a large feed rate, thus creating threads. So different processes are shown here. The first process is a facing process where we remove material from the end faces. A taper turning at an angle. Here this is vertical feed, direction of feed is vertical. At an angle we produce taper, tapered surface, taper turning. Then C is contour turning, at a contour profile is produced. Then the next is a form turning, where we use a tool having the similar shape of the part to be produced. Specialized tools are used to contour turning. Then chamfering, the edges are smoothened with the help of chamfering process. As you could see here, some amount of material is removed in cut-off tool. Specialized tool are used, and the tool is fed inwards in a rotating workpiece. And then threading, as I explained, feed is controlled, and the feed and the profile of tool are selected in such a way that we produce threads on the cylindrical workpiece. So these are the different important processes, and the processes are done in a machine called an engine lathe machine. Here the important parts of the engine lathe machines are headstock, tailstock, then carriage, tool post, cross slide, etc. So headstock carries the power production, or the motor is fixed in headstock. So the necessary speed or rotation of the workpiece is provided by the headstock. There is an electrical motor. As it rotates, the workpiece also will be rotated. So workpiece is connected, and the spindle here using chucks. Workpiece is connected. As we switch on the machine, the motor will rotate. So the headstock, the workpiece also will be rotated in here, and it is supported with the help of tailstock, and the workpiece is held between the headstock and tailstock, and the tool is moved in a specific direction. Feed and depth of cut are given to cut threads or turning or whatever, or facing. So whatever process is required, depending on the process, the tool is fed whether horizontal at an angle for taper turning, or a profile, etc. So these are the important parts. So we could move the table accordingly. So depending on the requirement, we could move the tool by moving the table. Now, the work holding devices, there are different work holding devices as given here, holding work part in different centers. These are chucks, different holding devices are given here. So this is holding the work between the centers, tailstock center, you can see here center, and then a dog clamp to work driven by a dog plate. This is supported by the centers, and next is by the chuck, 3-jaw chuck, 4-jaw chuck, etc. Then by using a collet we fix it, then by a face plate we fix it. Then what are the equations applied for a turning machine as cutting conditions of a turning? So as I explained before, the speed of rotation is calculated as velocity divided by cutting speed velocity divided by pi d naught. D naught is the original diameter and v is the cutting speed, meter per minute, and n is the rotational speed. So the final diameter equal to initial diameter minus 2 times depth of cut. Using this, we can find the final diameter. The feed in turning is generally expressed in millimeter per revolution, which is F. This feed can be converted into linear travel of the tool by expressing them in millimeter per minute, which is called feed rate. Feed rate is equal to NF. N is the speed and F is the feed in millimeter per revolution. Time required for cutting is the length of travel divided by feed rate. Using this, we can calculate time required for machining. So time for machining can be calculated as pi d naught L over F times V. Pi d naught is the outside diameter, L is the length, F is the feed, and V is the cutting speed. Using this, we can calculate the time required for machining. Material removal can be calculated using the equation VFD. V is the cutting speed, F is the feed, and D is the depth of cut. So sometimes we go for advanced machines like turret lathe. So in turret lathe, the tailstock is replaced by a turret that holds up to 6 tools. The tool post replaced by 4-sided turret to index 4 tools. You could see here a turret replaces the tailstock so that you can use multiple tools at a time. So such machines are used for high production work that requires a sequence of cuts on that path. So thank you very much for listening. Thank you.